extra strong Roman concrete,
fully hydraulic,
structural solid connections.
It's the
Structural engineering podcast.
Welcome to this week's episode of the Structural Engineering Podcast. My name is Max.
My name's Zach.
And this week we're talking all about mechanical engineering.
The kind where they're putting holes in our structure. This episode will be pretty good. We have a guest. Carl's a mechanical engineer. But before we get to Carl, Max, let's talk about a little bit of your experience with mechanical engineers. Do you like them? Do you hate them? Is it a love-hate relationship?
I've had nothing but good times with mechanical engineers. They poke a lot of holes. They make it just a little more fun to do your job, you know?
I totally agree. I think when you have, a steel beam and they want 30 holes in it, it gives you the opportunity to have a castellated beam.
Yes, exactly. We're both getting on a good point here, which is most of the interaction with mechanical engineer is avoiding a structure with mechanical. So coordination is like an absolutely huge thing with mechanical engineers. For me, I rarely actually even interact unless it is moving a structural element out of their way. But you should interact more. They're good people.
Yeah, I think they're good people. And good mechanical coordination and working together as a team just brings a better product at the end. So I think it's important to understand how to work with your mechanical engineer for the project, and what are their needs and what are our needs that they need to understand. And so hopefully this episode, talking with Carl, you guys can have a better understanding of what the mechanical engineer kind of needs space-wise, what kind of their different systems are, and how you can help drive efficiencies with the structure with respect to mechanical. So let's jump in here with Carl and introduce him.
Wait. This conversation with Carl is going to be a two-parter. We had a great chat with him for over an hour, and we thought, well, we'll just keep most of it and make it 2 30-minute episodes. So enjoy. Ooh, and this two-parter is the end of Season 1. We'll be back with Season 2. We've already got 4 really cool interviews lined up for December and early January. So we'll be back with you, early, mid-January. Get on with Season 2.
Thanks for having me. I'm glad to be here. I hope I don't embarrass all of mechanical kind in one episode, but my name is Carl. I've been a practicing mechanical engineer for over 5 years. I have an architectural mechanical degree, and when I say mechanical, some firms kind of will have an engineer specialize in HVAC and a different engineer specialize in plumbing. When I say mechanical, I usually mean the combination. I do both mechanical and plumbing. And all the stuff that, as you just said, puts holes in everything you're trying to do.
And we thank you for it. I want to ask about mechanical engineering education. That's something I've always been curious about. Seems like a good, the very basics of this. A degree in mechanical engineering, as you would typically see it, you did architectural mechanical. That fits. Are there people that are in the HVAC world that did a more traditional mechanical engineering, like gears and pulleys education?
Yes. There's not very many school programs that I have found that have the mechanical emphasis that do what our job is. A lot of them are a little bit more of that general mechanical degree, and you're just looking for, a lot of it is just a lot more thermodynamics. Mm-hmm. And so you just look for mechanical engineers with more of a specialty in thermodynamics. Oh. And they usually do well in the mechanical industry.
A funny thing to kind of jump in there with Max is I think it was junior year in college. I was walking through a career fair. Train was there, and their salespeople are also their engineers, right? That's what they sold me on. And they said, "What kind of engineering degree are you going for?" And I said, "Civil structural." And they said, "You're perfect for the job." And I was so confused. And they said, pretty much, if you know fluid dynamics of any sort,
really,
they'll hire you. They said they've hired marine engineers, aerospace engineers, pretty much anything, as long as you have a good understanding of fluid dynamics.
Wow. Well, I guess you have pipe flow type classes, right?
Yeah, you do. You do some fluid dynamics. Then, as I said, thermodynamics, kind of your specialties. We get into a little bit more of design, but to be honest, the stuff you mostly get taught in school is not regularly used.
Yeah.
I don't have to do fluid flow calculations pretty much ever. I don't have to.
But you need to understand how to.
Right. I mean, you need to understand what's going on.
It's like you get the fundamentals in school, and
Yeah.
does mechanical HVAC feel like you do more of the training on the job? On your first day, did you have a good grasp of what was going on, or was it like all so new to you?
I had a good grasp of the components they were trying to work with. The methodology used to design and lay out these systems was super new. And the challenging part about mechanical, which I think structural shares, is that every job is so different. Like there's no just like, okay, well, like I just reproduced what we did on the last job.
Yeah.
Like every building has its own client, its own occupants, its own comfort. So it's a different problem every time. And it's part of why I know that's why I like being a mechanical engineer, is because it's always this new challenge of how to be more energy efficient, how to get the best system, how will things work,
and how to make the structural engineer have the most challenging, difficult.
Absolutely. If I didn't do that, I didn't do my job right.
When did you decide that you wanted to be a HVAC mechanical engineer? I feel like in high school I wouldn't have even known this was a thing. I didn't know structural engineering was a thing, really. So,
do you currently know that it's a thing, Matt?
Well, so I don't know how good of a applicable of a story this is to your listeners, but I knew I wanted to be an engineer, but I had no idea what type. And I was in a classroom once, and I overheard other kids in the class, "Oh yeah, I'm going to go be an architectural engineer because that's where you go if you want to be creative." And I was like, "Oh, I want to be creative. I'll go be an architectural." And then our schooling program had two emphases. You can either be architectural structural or architectural mechanical. And I was like, everyone's always talking about energy and being more energy efficient, and it's the big driver of everything. So I was like, there's got to be jobs in this.
Oh yeah,
there's going to be a continual career for this.
Absolutely.
And so I'll go do this.
And you kind of went against the norm, as everyone wanted to be a structural engineer. Is that correct?
Correct. Our program had about 36, 40 students that were structural emphasis, and there was 3 of us who were mechanical emphasis.
Whoa.
The black sheep of the family.
Yeah. And there are a lot of mechanical jobs, right? I mean, it is a booming industry.
Yes.
Okay. So, Carl, we work together. I guess that's something new to introduce here to the podcast. Carl and I work together, and obviously
I regularly poke holes through your structure. I'm the nightmare.
Carl often comes to my desk with very large holes in my structure, and I try to hide from him as often as I can. So Carl, we've talked a lot about how we can coordinate things better and grow, and really what it comes down to is having a better understanding of what causes issues for each other and at what time and what stages that occurs. And then on top of that, we've talked a little bit here about openings in the structure for your different elements. Piping or ductwork is typically what it is. Luckily, with electrical engineers, we don't typically deal with them very much. A little conduit can kind of just find its way wherever. But then, Max brought up too earlier that we also have to deal with weights of things. So I really think that to our listeners in this episode, if we can explain to them how they can better understand what you need and how to work better with you, then they can be better engineers of their firm and to their clients to be able to coordinate with mechanical engineers even better. So what if we start off here and go a little bit into kind of the systems you design? You said you do plumbing, and you also do kind of the HVAC mechanical side of it. So in a very general sense, what do those entail, and where in our buildings does that run?
It's a little broad of a question to try and answer because we're pretty much everywhere, and we're in everything. The saying I have about a mechanical system is probably a pretty similar aspect to structural, is that if I did it right, nobody knows it's there. Everyone forgets about it. You should never have to think about where the water goes when you flush the toilet. You should never have to think about whether your room is comfortable or not comfortable. It should just be working. And other stuff like architectural finishes and everything goes places, but our stuff has to happen. And so we're in the wall space, and all the wall cavities just having to share it with structure, and we have to get to all of these spaces just as much as your structural has to be there to hold it up and stop it from collapsing. And there's no really easy way around it. You said that, a lot of this comes down to mechanical coordination. And I think what will define a good mechanical career for any structural person is how well they coordinate with you. Mechanical ends up in the center of basically everything. We have to coordinate with electrical to power all of our stuff. We have to coordinate with structural to keep it all up. We have to coordinate with the architects to lay it all out. And then we have to coordinate with civil to connect it all outside of the building. And there's not really besides the architect, other disciplines that have to be so well coordinated.
I've never spoken to an electrical engineer, so.
I have to go when I have to read civil drawings. I have to go read electrical drawings. I have to go try and read structural drawings and decipher all their jargon.
I have to jump in real quick. This is a good little quick story about Carl. He came over to me one day, Max, and he goes, I got to put these drains in the slab on grade. I said, okay, that seems normal. He goes, but on the structural drawings, they're calling it out as something called PT. I said, oh man. He goes, how bad is it? I said, you can't just be chucking holes all over that thing. Those have to be very well coordinated. And Max, it was very interesting. It was actually a waffle slab PT system on grade. It was a really cool system. Again, to what Carl's getting to is he has to be able to understand our drawings and understand what everything we're trying to do is. And he understands what a beam and column and wall, and he really understands what a shear wall is because he tries to find those as much as he can. But the more educated we can be about each other, I guess what I'm trying to get to is the better we can be and the better we can plan. Now Carl knows what a PT slab is and how difficult it is to put openings in it. Mm-hmm. So I'm guessing next time Carl sees PT, he's going to think earlier on that he needs to, push that to the engineer. And the structural engineer also, obviously needs to be upfront and coordinate stuff with that to the mechanical engineer. And, if you're not dealing with Carl, who already knows this, you kind of have to educate your mechanical engineer.
Yeah. I'm curious, Carl, when do you start to see a project? When you're looking at kind of a schematic, is it the architectural, like we first get, it's just a floor plate? Are you looking at that and assuming where structure will go and start to lay it out?
Okay, so structural honestly tends to be one of the later coordination things.
What? I thought we were the most important.
We begin our design with a lot of theoretical high end because there's so many solutions to the problem. There's a lot of early theoretical discussions about what kind of systems we're going to use, how much the client is willing to pay for these systems. And then once we kind of have that, we start to talk about okay, well, where are they going to be in the building? Are they going to be on the roof? Are they going to be in a shed in the back? Are they going to be in the basement?
Please be in the shed in the back.
And then once we have them, it's okay, well, now we know where the stuff is. Let's talk to structural about, okay, we're going to put it on the roof, or we're going to put it in the basement, and we're going to have to go through your shear post-tension walls and floors to get there.
Man, now that I know there's a shed option, I'm pushing that every time.
I never knew there was a shed option. That's freaking genius.
You could just put it on the grade if you really get...
No, I like the shed. I'm going to start specifying Home Depot sheds.
But so the example Zach was talking about, the job had been quite progressed a fair way through, and we had sent some plans to the structural showing all the locations that I had plumbing fixtures above the slab, and he had gone and said, okay, well, I don't have any waffles. I don't know. Sorry, the words for the vertical members of the waffle.
Let's call them beams.
The beams. He's like, I don't have any of the beams under your fixtures. And I went and I finally start to pull up his drawings, and I look and I overlay them, and he didn't because he put them on the wall behind your toilet. But that's where all the pipes are that serve all the floors of toilets. So that's where I'm going to be punching through. I don't punch through underneath the fixture. I punch through in the wall behind it where all of my drains are. And so he didn't understand that, okay, because the toilet is sitting over not a beam, it's going to be fine. Let me put it under the wall where I have all my pipes. And so we had this big kind of like fire drill of having to figure out and move a bunch, and he had to figure out how to let me penetrate the beam all over the place. And it was like, okay, well, we had tried to discuss this early on, and I didn't understand your structure, and you didn't understand my plumbing system.
Yeah, and so us structural engineers being more educated in what you need and how your stuff works, and you being more educated in how our stuff works, creates just a better system and better overall. And to me, Max, if I would have known all this stuff year one, year two, I feel like I could have done a lot of things differently.
Oh yeah.
But I think as a young structural engineer, that's like the last thing you're learning. You're not starting day one and they're like, let's walk through some mechanical systems.
Oh yeah. You have so much on your mind structure wise. It takes a couple of years to incorporate anything else.
Yeah, you're like getting calls from an architect, like, how are we gonna put this duct through there? And I'm like, I'm just trying to figure out how to design the lateral system. So Carl's example is perfect. If you ask the right questions halfway through the project, call the structural engineer and be like, hey, I've got holes I've got to put through your slab. Is that a problem? Or as a structural engineer, if you're doing a PT slab, call the mechanical engineer and just be like, hey, just want to make sure we're on the same page of how you can put holes in my structure. The funny thing is, as the longer I stay in this industry, the more I realize the solution to all of these things is just communication. Like, it's good to know how to ask the right questions. You could call the mechanical engineer and be like, hey, do you have any holes in my structure? And like they'll just go off and tell you everything. Like, it could be such a simple question. So
oh yeah.
Anyways, I'm glad to hear you guys work through that. It kind of sucks it was a fire drill, but now you know, right?
Right.
So
how often do you get calls from engineers and just ask ahead of time, what is your system looking like? Where might I expect to have some penetrations?
For me, I don't think I've ever had a structural call and ask those questions.
I think, it's really a after design for us is how I have kind of operated. And I wish it wasn't the case. It's, hey, here's all my structure. Are there any holes in it now? Like, do you need to put a hole in my structure versus what is the system going to look like overall?
Right. And there's where, having a good team and why I think, having Zach and I work really close together on projects and can really coordinate well, being in the same office gives an advantage to that. For those of the listeners who aren't in the same office, just reaching out and opening those communication pathways is going to be really big. The other thing I think is a valuable thing is that for the industry's changing. My first job I ever did was the first job our firm has ever done in Revit. And now we're 100% in Revit. And what seems to be a big difference mechanically versus structurally is that structurally you guys tend to seem to still use drafters a lot. You have your designers and your drafters. Mechanically, we're moving away from that. Revit is becoming a design tool instead of a drafting tool for mechanical engineering. And so we're seeing basically our whole design being inputted and designed through Revit. So our models tend to be a lot more accurate and a lot more useful if you can use that as a coordination tool to help point out points of concern and issues.
So if with you being in Revit so much, I know Max and I are not in it obviously as much as you are, but spend some time in it. When you're going through and modeling, let's say your duct work and your piping, do you just have a mechanical engine, or do you just have the architectural backgrounds in your Revit model, or are you also pulling in the structural model? And I'm guessing at some point you're gonna say you do pull in the structural model, and if so, when does that occur?
We would pull it in as soon as we can. It tends to be a matter of the validity of your model. Usually I find that structural models tend to be more like you guys don't model all of your beams and joists and all of the components early on that we need to see. You have other tools that you're using to do your calculations and designs. And so having a 3D representation of those isn't much value to you in those early stages, even at all. You probably just have to do it just for us.
More or less, I find that the 3D model is really good for clash detection between architectural and mechanical and structural. I mean, they're going to build it off of 2D drawings majority of the time.
Right.
I know there's a small percentage of stuff that there's contractors using 3D models to view it and do everything, but there's a lot to, they're just building off 2D plans.
Absolutely. But what you're getting at, Carl, I think is like, we do not use Revit at all in the beginning for our design. I think you're absolutely right with, like, we are kind of doing it just to keep coordination moving, but we have a whole separate analytical model, whether that's in RAM or RISA. You can bring in some stuff from other software packages like Revit, but we're entirely working elsewhere. Yeah, so we just bring it in to show it to you guys. So it definitely makes the coordination right from the start a little harder.
So I have a question for you guys. What point in your design, I know you guys will pay attention to floor-to-floor heights, but do you ever look at how high the ceilings are in a space?
I would have to say I've never really looked at that. Honestly, unless it's a problem that pops up, and it's usually from mechanical or architectural, they call and they say, hey, your structure's too deep. We need to shallow it up. The ductwork came in deeper than we expected. The ceilings are too low. Or ceilings are too low. The ductwork needs to go through all your beams in the floor. So we're going to punch holes in all your structure.
So there's where I think that causes the point of contention is your ceiling, because I've got to fit above the ceiling. And if you guys don't even know where it is, and you're laying out how deep all your joists are going to be, that's a huge effect on me. I've had instances where I've gone in and I've like got to a room in a design. I was like, this guy's got 30-inch beams, and I've got 36-inch space above the ceiling. I can't move my ductwork in 6 inches. Like that's a 4-inch tall duct, and then I have to be. So I'm also have another factor. So like if I've got however much ceiling space, I have to leave 6 inches of space above the ceiling for lights. So whatever the bottom of your joist is, the top of the ceiling, subtract 6 inches, and then that's all I have to work with. So if you're not giving us space there, knowing what that depth is, we as sure as hell are going to find out no.
Man. Right, and it's such an interesting point. I would say usually I'm assuming the architect is planning the routes for most of that early on, chases and joists through the corridor, so it's a little shallower, so you have that room in that ceiling. I would say I usually leave that up to the architect to find that issue. Now, if you're doing open web steel joist, you can go through that.
Correct.
And that can solve it.
A lot of issues.
But we're not using that for a lot of floor systems. It doesn't perform very well. Open web steel joists constantly have vibration issues of your floor system. So it's usually a wide flange system. If we're talking about a steel building, or if you're doing a concrete building, it's a little bit different, but there's still, we're taking up some sort of space.
So I usually think of it as being on the architect to, he kind of knows, he or she, the depth of our structure. We're kind of limited, based on the span. You can make some pretty good estimates. So I guess I have always expected that would be pre-thought of a little bit, knowing how deep we're going to have to go. But maybe that's not the case.
Especially, I've always thought the architect's got a good feeling of, like, they're setting the floor height, right? But they don't necessarily talk to us, the structural engineer, or the mechanical engineer to set the floor height. That's kind of just like, well, we've always done this and it's always worked. Yeah. But if you all of a sudden have crazy spans, that's going to start getting deep. It's a weird, like, we should probably all get in a room early on and say, okay, my structure, 5-inch slab, 24-inch girders, right? Here's my depth. And then you come in and say, I need 18 inches of space. They say, we want this ceiling height, and then boom, there's your floor to floor.
I did actually have a really good one recently, a well-coordinated project that we knew halfway through we were going to have some giant cantilevers and they were going to be wicked deep. So we basically set a line of, we can't be deeper than this with our structure. If we're between this and this height, we're putting penetrations, and anything above that, no penetrations. So it just set this perfect bar, We knew exactly where we were going to end up. If we could do that every time, it'd just be wonderful.
Well, and it's hard to know ahead of time and be able to prove, like a lot of times the architect's like, well, you guys will find a way to do it with 10 inches of space. And I recently had a job that we started and they're trying to design, and we're like, there's not enough space. You got to lower the ceilings or something. And they're like, no, the owner is very specific. They want the ceiling height. They will not lower the ceiling. And I just kept coming and be like, I can't fit. And to the whole point that I drove the owner they raised the whole building. They were so set. They made it 2 feet taller. You got to give me the space somehow. They're like, well, we're not going to sacrifice our ceiling height. So
yeah, this is probably a hard question to answer specifically, but how much space do you need? Can you say this building is this square footage? Our ducts are probably going to be 6 or 8 or 40 inches. What? Yeah,
Well, so
where do
there's
you start estimating?
I can take some swings at it. So like the most common system that we'll see pretty much universally is a rooftop unit, an RTU, with a VAV reheat. And what that means is for each VAV box, we call it, it's a variable air volume box, we have one thermostat. And so, like, say you have a school or an office building, we'll have one VAV per classroom or one VAV per section of offices. And in those kind of systems, it's the most common mechanical system you see installed nowadays. There will be a large trunks that will have to go from the RTU down probably your corridors or your central walkway paths. And those will be the big ducts, and they'll probably be at least 20 inches deep. And then off of that, you'll have about 12 inches you need for the clearance of the space on the stuff on the side. Mm-hmm. As each VAV box taps off the main, a VAV box itself is 10 inches, I think, 10 to 12 inches tall. And so you can't really get smaller than that. We can do stuff and try and put that between. Like, that doesn't have to fit under every joist, but we're going to need to pinch down and have those ducts go under a joist. But really, if you're ever under 10 inches of space, you're not really giving us any space to work. And as I said, whatever space you have from the bottom of your structure to the top of the ceiling, 6 inches of that I can't even touch.
Tell me about the difference between a circular duct, oval, square. Why can't you do a 36-inch by 1-inch duct?
Okay.
Just coast. I mean, I get there's loss, but hit me like what? Where?
So very simply, well, there's kind of two questions you asked there about the sizes versus the ratio of height to width. Height to width, the more square you are, the more efficient it is to move the air through the duct. Mm-hmm. The more rectangular we get increased pressure drop. And the more pressure drop we have to push the air harder to get through, which starts to increase fan power and energy consumption, mm-hmm. and all of these things that, we have codes now that are requiring so much energy efficiency and limit our fan power usage to move so much air. And so we're trying to be as efficient as we can and reduce the energy bill to the owner. Mm-hmm. And so the more square we are, the more efficient our system is. Square is easily efficient. The rounds usually come pre-made in a certain size. And so they're super cheap to, like a 6-inch round is super cheap. It's sold by a 10-foot section, mm-hmm. where the squares are custom bent. You have a sheet metal contractor who will come in and bend the duct to be a 20 by 12. Hmm. And so we can get whatever size we want. And then ovals, like super custom and super expensive. And you really only see it in like exposed places where they want to be super fancy and have that smaller dimension. Yeah. And be higher up, but still look fancy and look round. And so the value of oval is its look.
I always thought the oval were just the circles that fell off the truck. Okay, cool. So, yeah, you want it to be as square as possible.
So, yeah, our big driver is fan efficiency. That's the big, we have the International Energy Code now that's really driving our minimum productions and how much power we're consuming. That's what makes my job fun for me is to try and come up with the most energy efficient and power saving building that I can get an owner. And it's all done by trying to be as efficient as possible with getting what I have to that space.
Now, you're saying here just a little bit ago that your main's probably about 20 inches deep, right? Off your RTU, let's just say
just a super rough number.
Super rough number. How much do you think that has changed in the last 20 years? Because now you're saying more efficiencies and et cetera. I hear architects saying all the time that, oh man, we got to raise the floor to floor, but we've never done this before. Like, we keep raising the floor to floor because of mechanical efficiencies. What does that statement even mean? To me, that means the ducts are getting bigger. Well, if we're getting more efficient, why are they getting bigger?
Well, because they're getting bigger, they're getting more efficient. So we're also getting better at routing it, but it's coming because, it's all about power. And it's all about reducing that energy bill. A lot of schools are doing crazy things like we have systems that will make ice at night when the power bills are cheaper because they charge you more during the peak hours, like when the kids are in school for your power bill. So they'll make giant blocks of ice at night when the power is super cheap. And then during the day when power is super expensive, they just run their chilled water through that ice block and use the cooling from that ice during peak hours to reduce their energy cost.
Now, I got to tell you, I don't think anyone's ever asked me how much ice they can put on my floor. That sounds heavy.
Those go in the shed.
I've only ever seen them in basements, to be fair. So
here you go. That's the halftime buzzer. Stay tuned for round 2.